at this moment. And so let me just check because I want to see if YouTube has registered it. Yeah, it's supposed to start right on time. So Ben, are you ready? Are your slides done? Because as I understood, you have just finished them. So.
No, I was just looking back over them. Yeah, they're done.
Okay, great. And I do think that, Ben, you are on the staff of Next AppSec USA, right?
Yeah, I was. Yeah, I was on the speaker selection committee.
Okay. Can you tell us a little about like the subjects and all the stuff we will see at AppSec USA?
So the way it worked was that everyone on the committee received a big list of submissions, and we all voted on them. So I actually don't know who won.
Okay.
It was a lot of enterprisey Java stuff that I wasn't really into, but there was a couple cool new talks on web application security stuff that was a bit more general, like some new browser security features and that kind of stuff. So that was a little bit more up my alley.
Okay.
I shouldn't talk bad about Java at a OWASP thing, though, because I know there's a lot of Java developers at OWASP.
Yeah, it's like it's Java. No, by raise of the hands, how many of you guys are like Java all over the place at the workplace and stuff like that? So it's only 2, 3, 4 out of maybe 20. So
that's good to see.
That's yeah. Well, it's with GitHub and the way we have actually advertised this one. It's like, you just come see it's GitHub, it's open source and stuff like that. So it's not as pointy as we might have in some presentation that we might do just Java. So it's working. So that's great because everything was actually set up ahead. So Ben, let me do an introduction. Well, welcome to OWASP Montreal. The introduction will be short because I'm already talking to the crowd since maybe 15 minutes and they are bored of me, but Ben is here and he will do his presentation on GitHub AppSec, I'm sorry. And I want to read to you the presentation because, well, it's very like abroad the subject, as might say. And I actually spoke with Ben at last PyCon in Montreal, and that's where I got this idea because I was like, it's interesting to see what they do in other workplace that actually have to deal with AppSec and stuff like that. And GitHub is a great example, is like very known on the web and stuff. So without any more blah blah on my side, Ben, it's up to you. And if you can speak loud and clear, I will just go see in the room if we can hear you well. So you're on.
Alrighty.
Thank you.
You can hear me all right?
Yes.
All right, great. So I started at GitHub about 2.5 years ago, and I was the first person working on application security at GitHub. My background was in consulting. I was a penetration tester. So the first thing that I did when I got to GitHub was I went out and tried to find all the vulnerabilities. And for the first month I was at GitHub, I just found vulnerability after vulnerability, and it was a lot of fun just getting to own stuff. And my thought was that I would just find all the vulnerabilities and then I could go home and have a beer. But it turns out that that doesn't work and that doesn't scale. So this talk is going to be about where we went from there and how we built our application security program over the last 2.5 years. So my name is Ben Toews. As I said, my background is in penetration testing and development, and I've been at GitHub for 2.5 years, and I think that's all I need to say about myself. So at GitHub, we write a lot of code. GitHub has a culture of shipping. We try to move fast. We try to always be deploying code and shipping new features. In the past month, or in an average month, these slides are getting a little bit outdated, we see tons of development. This page shows the activity just for the GitHub repository, which is where we keep the main Rails application. You see that in that month we merged 648 pull requests. There were 93 authors making 2,978 commits. Across all of our repositories, there were 16,150 commits in that month. So a good deal of our code is vendored in or coming from libraries that we own. There's also an incredible amount of code that we're bringing into the repository from open source libraries and whatnot. So it's a very fast-moving target, and trying to keep up with that from a security perspective can be a challenge. What makes this even more challenging is that GitHub has a culture where we try to reduce friction. We don't want people to not be able to do their job, to ship software, because of security. Friction is anathema to GitHub culture. So when we're trying to secure things, we need to make sure that we stay out of people's way. So with these limitations in place, with a fast-moving code base and with a culture that doesn't allow for friction, how do we do AppSec? The first thing that we start with is really good developers. GitHub has a history of only hiring senior developers. This means that we have people who've been around the block a few times, who know what cross-site scripting is, and we're able to treat them more like adults. We don't need to assume that the people that we're working with are ignorant and that they're going to make really junior mistakes. We're able to give them a longer leash, in a sense. Also, GitHub has always had a culture of security. The leadership at GitHub cares a lot about security. When I started at GitHub, the person that I would call at 3 in the morning if there was a vulnerability that needed to be patched was the CTO. And he would wake up and would not complain and would help me fix a vulnerability. So our leadership has always cared a lot about it, and that trickles down through the rest of the organization. And having developers that care about security because their bosses care about security means that people aren't afraid of us, and people want our help because they want to ship secure software. And through this, we build a culture of trust. We encourage developers to ask us a lot of questions and to CC us on pull requests. If they're not comfortable with something, or if they're not 100% sure that what they're doing is safe, we would rather them ask us than to ship it and then we find it down the road. And because the developers trust us as well, they're very apt to do that, and they don't need a lot of push from us to get them to come and ask us questions. When we hire people, we do a very light-duty developer training. We write a lot of documentation. We have a huge markdown file of common security problems that we see and best practices. When we have a new developer join the team, we show them these docs and we walk them through it. And we also try to get a sense of what their weaknesses are from a security standpoint. So we'll sit down with a new developer and we'll just chat with them, and we'll ask them if they think that their knowledge of security is good, and if they think that there are some weak spots, or if we find some weak spots, we'll point them to documentation, or we'll point them to other learning resources where they can become more proficient at security. We're also not afraid to say that we don't know. We have a lot of developers at GitHub who know way more about security in very niche areas than our security team does. For example, there's a number of developers at GitHub who write a lot of C code, and while anyone on our team, the security team, could review that code, the C hackers that we have are generally much more knowledgeable about C security issues than we are, just because that's their area of expertise. So in addition to only hiring developers that don't write bugs, we do a lot of manual code review. And there's a few ways that this happens. First of all is that people will come and ask us for review. As I mentioned before, we try to get developers to feel like they can always come talk to us, can always come and ask us questions. So this will lead to a lot of our code review. The other thing that we've been experimenting with lately, which is kind of counter to what I was saying about friction earlier, is we're doing what we call a production readiness review, which is before a huge feature ships or before a big change is made, we'll sit down with a team of people and we'll ask ourselves, is this going to have any performance implications? Is this going to bring the site down? Does this new feature need to be reviewed by the security team? And in many instances, you know, it's a change that's just affecting CSS files and we don't think it needs review. But in other instances, This will lead to more thorough review of a new feature, and we'll work with the developer and try to speed things up by having them point to code changes that might be risky. The other way that we find things that need to be manually reviewed is through static analysis. We have a tool called Sentinel that I'll talk more about later that is tuned to be very false positive heavy, but those alerts don't necessarily go straight to the developer, they come to us. So if we see a developer trying to use crypto libraries, we'll get alerted and we can go in and review things, and we can do all that without getting in their way. So in addition to manual code review by our team, we spend a good bit of money on consulting. You know, why do it yourself if you can pay someone else 10 times as much to do a worse job? But seriously, fresh eyes are good, and consultants are really good at giving a fresh set of eyes. So I've been looking at the same code base for years now, and there are things that it would be very easy for me to miss, but someone looking at it for the first time might see. So every quarter, we will hire an assessment of the application, but in addition to that, we will hire experts to work on smaller tasks. So for example, we've been using more Golang in our stack lately, and we went out and found a Golang security expert who was able to review these new applications before we launched them. And the other nice thing about a relationship like that is that we asked that Golang security expert to work with the security team so that we could learn more about Golang security. So we were able to improve our own proficiency as well as just having this new application assessed. The other form of manual code review that we do is through our bounty program. We launched this program in January of 2014, so it's been over a year now. And in the first year, in the first 12 months that we were running this program, we had 1,920 submissions over 12 months. That resulted in 57 bounties being paid, so there's a pretty high false positive rate here. And we ended up paying out just over $50,000. Of those 1,920 submissions, 892 of them were valid submissions. They weren't spam, and just over 1,000 of them were spam. And the spam submissions are obviously pretty easy to deal with. You just mark them as spam, and then our spam classifier learns a little bit more about how to detect those. The not spam ones, that's still almost 900 submissions, and we only paid out 57. A lot of those are not necessarily spam, but it's people who don't know how to use a computer. But still, 57 valid reports is incredibly valuable, especially for the price that we paid. $50,000 wouldn't get you much consulting time. And of the 57 bugs that we paid for, that was several remote code execution vulnerabilities. That was a couple of cross-site scripting vulnerabilities that were able to bypass our content security policy. These are really high-quality vulnerabilities that you probably wouldn't even have been able to get from a consulting engagement. So in terms of the dollars that we spend, this has been probably our most effective tool in improving our application security. One question I get asked a lot when I'm talking about our bounty program is how much work it is for us, just dealing with the spam and dealing with the people who don't know how to use computers, as well as dealing with the valid submissions. This graph shows the first year of our bounty submissions week by week. You can see that the first couple of weeks we got a ton of submissions. That was really stressful. We were getting submissions in the middle of the night, and we wanted to be responding quickly and make it a really responsive program for these researchers to interact with. So there was 2 weeks of hell, but after that it tapered off a lot. And the low-hanging fruit, the simple cross-site scripting vulnerabilities that we had just missed, those all were found more or less in the first couple of weeks, and now we start to see a lot more subtle bugs. In the past couple months, we've had 3 or 4 browser 0 days reported to us. Some things like CSP bypasses. We had something with Safari sending cookies to the wrong domain. Like, people are sending us browser vulnerabilities, which is just amazing. And we're able to defend our users against these browser vulnerabilities weeks or months before the browsers patch things. So the quality of the submissions that we're paying for now are much higher, and the volume is much lower. So it's a pretty manageable program, and it's not a terrible amount of work for anyone on my team. So in addition to the 3 forms of manual assessment that I talked about, we also do static analysis. Robots will inherit the Earth. They're coming. We have a tool called Sentinel, and Sentinel is essentially a big wrapper around Brakeman, and Brakeman is an open source Ruby on Rails static analysis tool. In addition to Brakeman, Sentinel runs a bunch of regexes across all code that's committed to the GitHub repository. And these regexes are looking for things like usage of crypto libraries, usage of some Rails components that we don't think are safe anymore. And the way that Sentinel works is that when code is pushed, a webhook is fired from the GitHub application to the Sentinel server. Sentinel pulls down the new code, runs a Brakeman check, and it's able to diff the results between the base of the branch and the changes that are being made in the branch. So there's a bunch of false positives in a Brakeman scan for any sizable application, but because we're able to diff the results that are new to a pull request, we're able to just show those, and then it allows us to focus much more, and it doesn't become noisy at all. And then it takes those results and it generates a nice report for us, and then it will make a line comment on the diff in the pull request. So I'm going to give a quick demo. I was trying to put together a live demo, but that didn't really work. It takes a couple minutes for the scan, so I'm just going to show the results of it. Can you guys still see my screen? I'm going to blow it up a bit. So here I made a pull request, and I'm adding a new file. It's called rce.rb, and what it does is it finds a user based on a user ID that's passed in, and then it tries to execute their login as a shell command. So this is obviously not good. And the Sentinel bot makes a nice line comment here saying that this is possible command execution, user supplied data could lead to command injection. So Sentinel was able to find this, and this is obviously a pretty obvious case. But Sentinel and Brakeman are actually pretty reliable for finding certain classes of vulnerabilities. Static analysis will only get you so far, but it's very good at catching low-hanging fruit. So this is what the GitHub developer would see, and then we get a report like this, and this is for a different pull request, so it's different warnings here. But here is a command injection warning, and it tells us that the confidence is weak. It tells us where it is. It gives us the code snippet. Yeah, so it opens an issue for us, and then my team comes in and triages these issues, and once we've reviewed them, we close them out. It's a really nice workflow for us to be alerted of things that need manual review and then to do that review. So in addition to doing code review and trying to find vulnerabilities, we do a lot of proactive defense. We try to mitigate vulnerabilities that slip through in addition to just finding and fixing vulnerabilities. So for example, cross-site scripting. The user is providing input to the application, and that's being reflected back out into the HTML that's being viewed by another user. Rails itself is pretty good at catching this. Rails does escaping in its template language by default, so a developer has to work pretty hard to actually introduce cross-site scripting. Our static analysis is very good at catching this. It's pretty easy to look for strings that have been marked HTML safe, and if that includes any user input, that's pretty easy to spot in static analysis. Bounty hunters are great at catching this. When we launched the bounty program, we thought that we didn't have much cross-site scripting on our site, but we had a number of submissions, some of which were very intricate and impressive, and wouldn't have been caught by static analysis. We also have content security policy. GitHub was one of the first sites to roll out one of the first big sites to roll out a functional CSP policy, one that wasn't in report-only mode. And with CSP, we have a pretty good insurance policy. It's not bulletproof. We've definitely seen CSP bypasses, both due to browser bugs and some pretty creative trickery from security researchers. But we feel very confident that this is a mitigation for most cross-site scripting attacks. Another classification of vulnerabilities, weak authentication and session management. Rails is really bad at this. By default, Rails uses the cookie store for storing session, which is irrevocable. GitHub, we recently switched to using database for all of our sessions. We don't store the session cookie at all. We store a hash of the session cookie, so even if you were to break into our database and get a dump of it, you wouldn't be able to use that to authenticate as another user. We also do a lot of work to centralize our authentication code paths. When I got to GitHub, there were 20 or 30 different pieces of code in the GitHub application that were generating tokens and then authenticating those tokens for things like RSS feeds and email replies and things like that. But we have done a lot of work to centralize all that code, so we only have one token format now. And authentication all happens in a very small library. And our static analysis actually alerts us if anyone modifies that library or opens a pull request that's going to modify that library. So by centralizing things, we are able to review it very thoroughly, and developers don't have to reinvent the wheel when they need to authenticate an endpoint or when they need to do token authentication. CSRF, cross-site request forgery. This is generally just a developer using the wrong verb when they're defining a route for a new endpoint. Frameworks are pretty good at encouraging people to be restful and to use the correct verb. Static analysis actually doesn't catch this at all, almost. I think that that's something that would be interesting to look into for static analysis. I think that static analysis could do a better job of this. I think Brakeman could do a better job of this. The other thing that we've been experimenting with, Chrome recently released support for something called first-party cookies. And that specification says that you can, when setting a cookie in the browser, you can say that this cookie will only ever be triggered, or will only ever be sent with a request that is triggered by a first-party interaction. So if you are browsing to a page on github.com, it will send the cookie. But if you are directed, like if there's an image being loaded from another domain, so if on Facebook someone posts an image for github.com/user/destroy, the cookie will not be sent with that. So there's some cool new browser features for mitigating cross-site request forgery. The A9, insufficient transport layer protection. This has actually been a pretty fun journey for us. So since I've been at GitHub, we've always been HTTPS by default, and that's a good place to start. Unfortunately, the first time a user comes to the site, or when a user just types github.com into their browser, the browser will attempt to do that over port 80 over HTTP. So pretty shortly after the HSTS, the HTTP strict transport security spec landed in browsers, GitHub was using it. And what this does is it tells the browser that you should never come back to the site on HTTP. You should only ever come to github.com on HTTPS. And that prevents things like Firesheep and all these man-in-the-middle tools that are super easy to use. It prevents people from using that to strip SSL off of users' connection to GitHub. Unfortunately, the first time a user comes to the site, the browser doesn't know that GitHub is setting this HSTS header, so an attacker could still intercept that first request. GitHub was able to get on the HSTS preload list. So in Firefox and Chrome, if you look in the source code, you will see github.com and all subdomains are forced to use HTTPS. So even if you open up Chrome on a new computer, the first time you go to github.com, it will not allow you to go over HTTP for github.com or any subdomain. So that is pretty good. Things are pretty locked down at this point. Another transport layer attack that you see is certificate authorities issuing certs to the wrong people. So a few years ago, China issued a certificate for github.com and was intercepting traffic. And we were able to block that because we were using cert pinning. So with cert pinning, you tell the browser this is the only certificate that you should ever trust for this domain, even if DigiCert or some Chinese CA signs a certificate for github.com, don't trust it. This is the only cert that you should ever trust. So yeah, with HTTPS, HSTS, HSTS preload, and public key pinning, our transport protection is pretty tough. So a lot of these things, like thinking about being man-in-the-middle by nation states, it happens every once in a while, but it's not a common event. And the real-world vulnerabilities that we see are generally not exploited. So things like cross-site scripting, we have never seen an actual cross-site scripting campaign against github.com, even though we do see cross-site scripting vulnerabilities every once in a while. So the real-world attacks don't necessarily match up with the real-world vulnerabilities. So our team needs to be able to also defend against real-world attacks in addition to thinking about all of these awesome, complex vulnerabilities that may or may not ever be exploited. The most common attack that we see in real life is brute forcing. We see a lot of account theft because people choose horrible passwords or because people reuse passwords between sites. The generic solution for this is rate limiting. That will lock out an IP address after a number of failed attempts to prevent people from brute forcing the password. We took this a little bit further. We rate limit on login, IP address, and also password. So if we see a certain password being used against a large number of accounts, we will block that password from ever being used in the future. We also have multiple layers of rate limiting. So if you, for example, have 100 failed login attempts in a week for a certain login, that account is permanently locked until someone on the support team unlocks it. But if you see 5 within an hour, the account might only be locked for 30 minutes. So we have multiple tiers, as well as trying to rate limit on multiple metrics. This is all pretty effective. There's still room for improvement. A few years ago, I guess 1 year ago, we saw a big attack with 40,000 IP addresses trying to compromise accounts, and this was very hard to respond to with rate limiting because they had such a volume of IP addresses that it was hard to detect. Something that we've been experimenting with is using machine learning, using support vector machines to look at all the attributes of a login attempt, to look at the user agent and what headers it's sending and what country the IP address is in versus what IP address in country the user normally logs in from, using all these more complex metrics to evaluate whether a login attempt is good. So the rate limiting that we have is pretty effective, but it's definitely not perfect yet, and we have room for improvement on this. Just to share a story about how weak passwords and shared passwords can cause a lot of trouble. In October of 2013, Adobe, which I'm sure everyone has heard of, had a pretty serious compromise. It wasn't cloud related or anything like that. It was just one of their portals for going in and buying software was breached, and they lost 38 million passwords. And as we all know, cryptography is hard. So instead of hashing their passwords with something like bcrypt, they made the mistake of encrypting their passwords, which means that it's reversible. So someone who has the key can go in and decrypt the password and then log into the account. Unfortunately, they messed that up even, and they used ECB block cipher. So electronic code book means that you aren't using an initialization vector. Each block, each 64-bit block of plain text is just run through the cipher without any chaining, which means that attackers, people with this password dump, which was made public, were pretty easily able to use the encrypted passwords in addition to the password hints, which were stored in clear text, to recover the plain text passwords. So now you had, what did I say, 38 million plain text passwords out there on the internet. So in November of 2013, a year later, we started seeing this 40,000 IP address brute force attack that I was talking about. So in addition to the fact that these attackers had a huge number of IP addresses that they were coming from, they also had the plain text passwords to attempt to use for logging into GitHub accounts, or at least a good idea of what the password might be. So they might make 2 or 3 attempts per account. So rate limiting didn't actually help much here. We only saw about 5 login attempts per account, and we saw several thousand accounts get compromised this way. And what the attackers did with these compromised accounts is that they used it to buy or to authenticate to a cryptocurrency website. The currency was called Ripple, and Ripple was doing a promotion where if you authenticated to their service using your GitHub account over OAuth, they would give you some small amount of their cryptocurrency for free. So these attackers were able to steal thousands of accounts and were able to use that to profit pretty directly. And fortunately, we were able to detect this pattern pretty easily. We saw all these accounts being compromised and then all of them logging into this site with OAuth. So we're able to recover all of those accounts, reset their passwords, contact the appropriate owners. In other cases, attackers have been much more malicious and much less direct in their attempt to profit, and much harder to detect. But the moral of this story is account security, clearly. The rate limiting wasn't effective, but if users hadn't been sharing their passwords between accounts, their accounts on GitHub would not have been compromised. Also, two-factor authentication, turn it on. I assume everyone at an OWASP meeting knows that, though. The other big class of attack that we see in real life is DDoS attacks. This is also a pretty boring attack compared to all the sexy cross-site scripting, remote command execution vulnerabilities that we were talking about a little bit earlier. If you go to status.github.com, you'll probably see this, all systems operational. For a few months there, we were having outages all the time from DDoS attacks. It was never really clear why we were getting these attacks, but they were happening frequently and causing us quite a bit of trouble. The DDoS attacks are difficult to handle unless you're somebody like Google who can just absorb the attack. We've ended up mitigating this through a service called Prolexic, which we shift our BGP routes over to when we detect attack. We also have some dedicated hardware in our data center that's able to do some pretty aggressive filtering. Nothing terribly exciting, but security should be boring. These attacks, the ones that we see in real life, are not exciting, but that's good. Boring security is good, and yeah, security is hard. Just to kind of give a review, the approach that we've taken to building our application security program is to have good developers, to train them well, to do thorough manual code review, whether it be with consultants, the Bounty program, or the application security team, to do static analysis, to augment manual assessment. Yeah, and the boring attacks are the best ones. Yeah, I think that GitHub has pretty decent coverage from an application security perspective. There's things that we're working to improve all the time, but the low-hanging fruit is well protected against, and we are always working hard to find more vulnerabilities. Yeah, thank you. That was a bit short. I talked a bit fast. Are there any questions?
Well, that's great. It's like half an hour, like right on. So, is there anyone has a question for Ben? So, well, I do have one myself, so probably I can just ask the camera. How do you handle like the way you deal with the fix? No, that will be a bad question. Okay, how do you handle the way that you handle the fix with your developer in order to do the follow-up of what they have actually fixed with what have been found?
Yeah, so when we find a vulnerability, whether it be through the Bounty program or through our own review, we'll open an issue on the repository, and if it's a really simple fix, we'll go in and fix it ourselves. If it's a more complicated fix, we'll go look at the Git history for who worked on that line of code, who worked on that feature, and we'll CC them. And yeah, we generally have vulnerabilities fixed within a day. For simple vulnerabilities and things that come through the Bounty program, we try to have a turnaround of an hour or two before we have a fix deployed. Yeah, does that answer your question? Yeah,
so basically you are using GitHub at GitHubs in order to track for the defects with issues. That's
surprise. We use GitHub.
Any other people have any question about, well, probably like we actually cover a lot of the subject that is not just what they do at GitHub, but what we have in AppSec from their point of view. So if you have any other question, maybe to any of the subject we talk or about GitHub, just really feel free. I got this microphone for you guys. So, and if not, if you are actually too shy, well, I can just ask it in your place. So, oh, there's one shy guy at the end. Do you want to talk? Yeah, go on.
Quick question. I want to know what's the ratio between the security team versus number of developers at GitHub?
That's a good question. I think we have 150 developers about right now. The title of the talk said 111, but I wrote these slides a while ago. And our security team right now is 7 people. And the AppSec team in specific is 4 people.
Thanks.
Good. So I don't know if we got actually a lot of viewers online, because I have been tracked on the view, because we can on our screen we can actually see, and there's actually 2 viewers. So hi to you guys. Most of the view will be afterward actually, and it's supposed to be like almost like 100 view. If you get 1 or 2 viewer, it's like that. So, well, I don't know if there's any other question. I would have taken the question from online, but since there's only 2 people, well, just send it a tweet to us, and probably I will get it like late because there's a delay on YouTube anyway. So any other question in the room? So I think I will just close on that. So a big thank you very much, Ben, just to have make this possible. But now we have a question. So just before the end, so go on.
The bug bounty system, did you guys started it? I think you were among the first to implement such a system, and it looks like it was very promising as a way to deal with complicated cross-site scripting attacks.
Yeah, we definitely weren't the first people to start it. I think Twitter, no, I think we actually beat Twitter, but Facebook and Google definitely had bounty programs. But yeah, ours we decided to make ourselves. We launched our program very shortly after things like HackerOne and BugCrowd launched, but they were new enough that we didn't really feel comfortable going with them for managing the program. If we were to start over today, I think that those are great, great services, and we would probably consider them a bit more thoroughly if we were to be launching a bug bounty program today. But yeah, we had a designer from GitHub come in and make our bounty site, and we wrote all the backend for handling and triaging submissions.
That's it, I think.
Well, thank you, and probably I will do another fake ending. So I would like to thank everyone that has actually come here. If any one of you still have a question. No? Okay, that's fine. Well, if you, I suppose, well, the slides, I don't know if you plan to publish it or not, but you can actually just go see on YouTube, and I'll have track on everything, and I will put the links if we do have one, Ben. So
yeah, I can send you the slides if you'd like.
Okay, great. And so I will see you at AppSec USA, I guess.
Yep.
Okay.
See you there.
Thank you very much.